Since I don't have any notes for Appendix C, binary, octal, and hexadecimal numbering system, I thought I'd record some videos to go over what the slides say. So what we're going to look for today in these presentations, there'll be approximately 5 or 6 of them. We're going to look at what does it mean for a decimal numbering system. What's it mean for binary, octal, and hex? How do I convert from decimal to binary? How do I convert from binary to decimal to octal, and so on? We'll also look at how numbers and characters are stored within a computer, which means we'll look at the ASCII and Unicode systems, and we'll look at how to add and subtract binary numbers. So let's look at the numbering system we use. It's called the decimal numbering system, and that's the one we use every day. It's based on 10 digits. Any idea why we chose this one? Well, one of the theories is it's because we have 10 fingers. And so we used a numbering system based on 10 digits. And as you know, the symbols that we use go from 0 to 9. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is also known as base 10, and I'll get to that in a little bit, why we call it base 10. But no other symbols are available, only these 10 symbols, 0 through 9. So if we want to go to a number greater than 9, we have to start combining the symbols. So if we go above 9, we'll use a 1 and a 0 symbol to represent 10, and then a 1, 1, and then a 1, 2, and so on. So we take them from the same pool of symbols, and we place them in certain columns. We have a tens column, we have a ones column, we have a hundreds column. So the far right column is the ones column, 10 to the 0. Anything to the 0 power is 1. So 10 to the 0 is 1. The next column is 10 to the 1, and that's the tens column. The column after that is 10 squared, or 10 to the second, which is 10 times 10, which is 100. The next column would be 10 cubed, or 10 times 10 times 10. Each time I move a column, I multiply by a factor of 10, and that's why it's called base 10. So if we look at a number here like 325, I can separate it into 3 columns. We have the ones column, which is 5 times 1. And let's see when we get it over here. 5 times 1. I've got the tens column, 2 times 10. And remember, this 1 is actually 10 to the 0 power. And then we have 2 times 10, which is 10 to the first power. And then we have 3 times 100, which is 10 to the second power, 10 squared. That's actually 10 squared. So if I multiply these out, 5 times 1 is 5. 2 times 10 is 20. 3 times 100 is 300. 10 squared plus 10 to the first plus 10 to the 0. And if there was another number, this would be 10 cubed and 10 to the fourth. But if I add 300 plus 20 plus 5, I get 325. So that's, if you look at this, this is a 3 times 100, 10 squared, plus 2 times 10 to the first, plus 5 times 1, 10 to the 0. So let me just erase this. There we go. So that's the decimal numbering system. 3 times 10 to the squared, 2 times 10 to the first, 5 times 10 to the 0. And anything to the 0 power is always 1. So here's a bigger number, 53,678, but the same principles work. We look at the 8 first. 8 is times 10 to the 0. We look at 7. It's 7 times 10 to the first. 6. 6 times 10 squared. 3. 3 times 10 cubed. 5. 5 times 10 to the fourth. We just increase the power of 10 by 1. Now if I look at 10 to the 0, it's 1. Anything to the 0 power is 1. 10 to the first is 10. 10 squared is 100. 10 cubed is 1,000. 10 to the fourth is 10,000. And I just bring down the 5, 3, 6, 7, and 8 and multiply them out. 5 times 10,000 is 50,000. 3 times 1,000 is 3,000. 6 times 100, 600. 7 times 10, 70. And 8 times 1, 8. And then if I add them up, 5,000 plus 3,000, 50,000 plus 3,000, 53,000 plus 600 plus 70 plus 8. So it's 53,678. And this little 10 down here means I'm in the decimal numbering system, or base 10. Now, besides the decimal or base 10 numbering system, we also have a binary numbering system. And this is the numbering system used by computers. Why? Because computers only know 2 digits, 0 and 1. 0 is off, 1 is on. So if you think of a light switch, 0 means off, 1 means on. And that's how computers actually work. They have millions and millions of switches inside, and that's how they compute things. 0's off, 1 is on. This is also known as base 2. And again, we have 2 digits, 0 and 1. No other symbols are available. It's either off or it's on. So if a number is greater than 1, we have to use multiple symbols, multiple digits. And we take them from the same pool and we place them in columns, just like we did with base 10. This is also known as base 2. So, again, we have 2 to the 0, which is 1. Anything to the 0 power is 1. And since this is base 2, we only go up by a factor of 2. The next column is 2 to the first, or 2. The column after that is 2 squared, or 4. And again, we keep going. 2 cubed would be next, or 8, which is 2 times 2 times 2. Or 4 times 2 if you want to go back one column. Or, let's see, 2 to the third, 2 to the fourth, 16, which is 2 times 2 times 2 times 2. Or just 8 times 2 if you want to look at it that way. So the column values go up by a factor of 2 as we move left in the number. So here's a number, 010000101. It's a binary number. So we have 0, 1, 2, 3, 4, 5, 6, 7. So it's 0 times 2 to the 7th, plus 1 times 2 to the 6th, plus 0 times 2 to the 5th, plus 0 times 2 to the 4th. So 0, 1, 2, 3, 4, we're right here. And let's see if I can do this a little better. Let's get rid of the eraser here. There we go. Nope, I can't get it. There we go. So now we have this 0. 0 times 2 to the third, which is that one. Then 1 times 2 squared, which is that. And this is looking messy, isn't it? 0 times 2 to the first. And then finally 1 times 2 to the 0. And again, if you look at the top ones, if I draw them, they'll just get way too messy. But there's the same thing. I start with, over here, I start with 2 to the 0, 2 to the 1, 2 to the 2. If I look at 2 to the 0, that's 1. 2 to the 1 is 2. 2 squared is 2 times 2, or 4, or 2 times this 2, if you want to look at it that way. 2 cubed is 8. To the 4th, 16. To the 5th, 32. To the 6th, 64. And to the 7th, 128. So now, looking at it that way, let's just multiply them out. What's 0 times 128? Well, that's going to be 0. Then we have 1 times 2 to the 6th, which is 64. 0 times 2 to the 5th, still 0. 0 times 2 to the 4th, still 0. Plus 0 times 2 cubed, which is 8, still 0. 1 times 2 to the squared, which is 4. Plus 0 times 2 to the first, which is 2, 0. And then 1 times 2 to the 0, which is 1, 1 times 1. So if I get rid of all, or if I multiply it out, I get 0 plus 64, 1 times anything is a number, plus 0, plus 0, plus 0, plus 4. 1 times 4 is 4. Plus 0 plus 1. So let's get rid of the zeros. We get 64 plus 4 plus 1. Well, if I add those together, 64 plus 4 is 68. Plus 1 is 69. So this number in binary, let's see, where am I at here? This number in binary is equal to 69 in base 10. So hopefully that made sense to you. Let's see if I can get, there we go. Let's just get rid of all this squiggly lines. There we go. So 69. So 10, 000, 101 binary, you can always put a little 2 after that, is equal to 69 in decimal. So let's look at this. Let's try to convert each binary number to its decimal equivalent. So we have 0, 1, 1, I'm sorry, 0, 0, 0, 0, 0, 1, 1, 0. So we have 0, 1, 2, 3, 4, 5, 6, 7. So the first one is 0 times 2 to the 7th, which is 0, plus 0 times 2 to the 6th, which is 0, plus 0 times 2 to the 5th, which is 0, plus 0 times 2 to the 4th, which is 0, plus 0 times 2 to the 3rd, which is 0, plus, let's see, 1 times 2 to the 2, let's see, here we go. Okay, there we go. I'm trying to get rid of the eraser. It's not getting rid of it. Okay. So we got 1 times 2 to the 0, 1, 2 plus 1 times 2 to the 1 plus 0 times 2 to the 0. So 1 times 2 times 2, this is 1 times 4, plus 1 times 2, plus 0. I'm going to put parentheses around that. 1 times 4, 4. 1 times 2, 2. Plus 0. So 110 to base 2 is equal to 6 base 10. So let's see if I can get the right answer there. Yep, it is 6 base 10. Let's try the next one. And let's erase this stuff here. Let's see if I can erase it. There we go. Okay, so now we have the same thing kind of again. We have 0. Let's see, got 0, 1, 2, 3, 4, 5, 6, 7. So I got 0 times 2 to the 7th, which I don't need to write down. 0 times 2 to the 6th. 0 times 2 to the 5th. 1 times, whoops, 1 times 2 to the 4th. Plus 0 times 2 to the 3rd, plus 1 times 2 squared, plus 0 times 2 to the 1st, plus 1 times 2 to the 0. So if I look at that, 1 times 2 to the 4th, 2 to the 4th, it's 2, 4, 8, 16. So this is a 16. 2 cubed is 8. 2 squared is 4. 2 to the 1st is 2. And 2 to the 0 is 1. So 1 times 16 is 16. Plus 0 times 8 is 0. Plus 1 times 4 is 4. Plus 0 times 2 is 0, plus 1 times 1 is 1. So we get 16 plus 4 is 20, plus 1 is 21. So we get 21. This is equal to 21 in base 10. So 0, 0, 0, 1, 0, 1, 0, 1 in base 2 is equal to 21 base 10. So did I get that right? Yep. Okay, good. It would be very embarrassing if after I do this, I got it wrong. So let us clean this up. And I'll let you do the next two yourself. And if you want, get out a piece of paper and try this one and stop the video for a bit, figure it out, and then come back. Okay, let's look at this. So this is equal to, let's see, 0, 1, 2, 3, 4, 5, 6, 7. 0 times 2 to the 7th plus 1 times 2 to the 6th plus 1 times 2 to the 5th plus 1 times 2 to the 4th plus 0 times 2 to the 3rd plus 1 times 2 squared plus 1 times 2 to the 1st plus 0 times 2 to the 0. So let's go to, let's start here. 2 to the 0 I know is 1, always. 2 to the 1st is 2. 2 cubed is 4. 8. 2 to the 4th is 16. 2 to the 5th is 32. And this is 2 times 2 times 2 times 2 times 2 if you want to multiply it out. 32, or it's just twice as much as the one column before it. 2 to the 6th is 64. And 2 to the 7th is 128. So I get 0 plus 64 plus 32 plus 16 plus 0 plus 4 plus 2 plus 0. So if I add these up, this is equal to 64 and 32 is 96. So I'll do 96 plus 16 plus 4 plus 2. Well, I know 16 and 4 is 20. If I add that to 96, I get 116 plus 2 is 118, I believe. Hopefully I did that right. 20 and 116 to 118. Let's check the answer. Yep, it's 118. So hopefully you're starting to get the idea of how to go from binary to decimal. And I'll just erase this. And then the last one is all ones. So again, if you want to stop the video, try it out, and then I'll work it through. Okay, so now if we look at this, we got, let's see, I'm going to put my pen here. 2 to the 0, 1, 2, 3, 4, 5, 6, 7. So 1 times 2 to the 7th plus 1 times 2 to the 6th, 2 to the 6th plus 1 times 2 to the 5th plus 1 times 2 to the 4th plus 1 times 2 to the 3rd plus 1 times 2 to the 2nd plus 1 times 2 to the 1st plus 1 times 2 to the 0. And again, I know 2 to the 0 is 1. 2 to the first is 2. 2 to the fourth is 4. 2 to the cubed is 8. 2 to the fourth is 16. 2 times 2 times 2 times 2. Or again, just multiply this one by 2 and I get 16. 2 to the fifth is 32. 2 to the sixth is 64. And 2 to the seventh is 128. So if we look at this, these are all ones. So what I end up with is 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. 128 and 64 is 172. Let's just put this down here, 172. All right, 192. Almost made a mistake, 192. All right, 4 and 8 is 12, 8 and 9, yeah, 192. 32 and 16 I know is, I'm just adding a few of the numbers together to make it easier, 48. 8 and 4 is 12, plus 2 is 14, plus 1 is 15. So 192 plus 48 and 15 is 63, I believe. Let's see, 5, 13, 5, yep. So this is equal to 3 and 2 is 5. 6 and 9 is 15. Carry the 1, 255 and base 10. Yep, 255. So we got that right. Let's see. Let's just erase all this. So hopefully you've caught on now on how to convert from from binary to decimal. You know, again, if you have questions, just post them on the discussion board or email me or message me and I'll answer them. But now let's look at the next step, which is a little more complex, and that's going from decimal to binary. Oh, just a interesting quote. There are only, and that's binary 2, types of people in this world. Those that know binary and those that don't. Remember, that's a binary 2. If you look at the videos, there's a video here, and it's a binary to decimal example. I want you to figure it out. What is the number? This is from Futurama. They always throw some, there is a lot of binary and base 2 jokes and things like this, and they have a little video. I can't show it here, but it is in your course documents folder for this section. Look at the video and see which is the number that scares Bender when it appears on the wall. So that's all I want to talk about here. We'll talk about in the next video starting with computer storage. Thanks for watching.